Everyone, good to be back. And here we are covering coordinate geometry. How amazing that can be, right? Sorry for the sticking of O. Bad teacher, isn't it? No, no, no. I'm not that bad when it comes to math. So, first of all, we're going to study slope of a line. And whenever I refer to line, please remember it's a straight line. Okay, so what is the slope of a line? Slope of a line is the steepness of line. Steepness of line, right? How much steep is that line? For example, if I take this line, so the measure of the steepness of line can be done by, let's just say, this line subtend an angle theta with the x-axis and in an anti-clockwise direction. So therefore, slope of such line subtending an angle theta with the x-axis on anti-clockwise direction, then slope of such line can be defined as tangent of theta, right? So because what and also now in GR you don't particularly have to remember this formula, but you have to remember that tan theta increases with increase in theta. So of course you do not have to remember tan 45, tan 60, you don't. Okay, you don't have to go in the literal value of it, but what you have to know is certain features of tan theta, which is tan theta, for example tan 45. For example, this there are two lines, one is this and the another, let's say this. Okay, so it makes even more line. Example, this is B and this is L. Here let's not say 45 because we don't know how much this is. We can just say this is theta 1 and this is theta 2, right? So tan theta 2 is, it's observable that theta 2 is greater than theta 1, and our theta, since increases with increase in angle, so tan theta 2 is greater than tan theta 1. So we can imply here that the slope of line L is higher than slope of line P. Actually, there are certain questions that are in your syllabus. I think you will find such question in certain GRE books where you will be given two lines. Okay, example here one line and another will be something like here, and they will ask you, okay, which one has the greater angle? And now it's pretty easy. I have already done it previously, but if you are confused, always remember it's all about the angle. Now, if you're confused to take angle from here, what you can do is you can also draw an imaginary x-axis here, and you can go here. This is theta, and from the same place, go, 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 go. You reach here. Now you have to further go to reach line L and M, line M. So here is theta 1. You can directly see theta 2 is greater than theta 1. Therefore, answer, if you're given question, quantity A and quantity B, which goes M and L, what should be your answer? It should be M, which is A. Please be aware of this kind of question. So this basically means quantity. This kind of question would not give you the options, but you have to understand by yourself. It means A is greater than B. B option means B is greater than A. C means A is equal to B, and D means relationship can't be determined. So this is the way GRE gives you whenever there is comparison kind of questions. So this is the first way to find the slope of a line, okay? But this is not enough for our syllabus. We need to understand that there are many other ways we can find the slope, and the second way and the most important way here is change in y coordinate divided by change in x coordinate. Let's just say change in y divided by change in x. Example, if you want, then any line here will be, let's suppose 2 comma 4, and 3 comma 8. What is the slope of this line? This is x1 comma y1, x2 comma y2, and this is 8 minus 4, 3 minus 2. 4 divided by 1 is equal to 4, right? So this is the next way, second way. And please remember, you will be given most questions from this one, okay? Because it's, I don't know, maybe it fits properly the most. So this is way much more frequent. Now the next one is the third way to find the slope of the line is, are you ready? Brace yourself, this is so fun. So the next way that you can find is, for example, I take a line here, right? So basically, what is this point here? And what is this point here? Basically, this is the point where the straight line touches the x coordinate, the y coordinate, and this is the line where the line touches x coordinate. Now, always remember that any straight line touches x coordinate and y coordinate only once, because since they are straight line, they will not bend, and for example, if a line goes this, it will not again go through this, okay? So we do not consider it here because we will consider a little bit of curve here. So this one is not a straight line. So here we always remember, you might think, oh, this is a straight line. This is a straight line. No, because this bending we do not consider here. So this is our straight line. So for clarity, here straight line touch x-axis and y-axis just once. Okay, so the value of any straight line regarding x and y intercept is constant. You remember I did this drawing before this? So this guy here is its x-axis, x-intercept, and this guy here is its y-intercept. Now, the slope of a line, can anyone tell what it might be? Okay, so this will be negative of y-intercept divided by x-intercept. Okay, and this thing, do not have to panic, they're constants. So by that logic, you have to be very clear. Another important point is straight lines have constant, no, let's not say fixed, constant slope. Okay, if there is a change in slope, there is change in slope, it is a curve. It is a curve, it is not a straight line. Okay, not a straight line. Got it? So this is the very basics. Okay, I like to give you an example because I used to get so much confused sometimes. So okay, before example, I'll just give you some before numerical example, let's see some line example. Okay, so I have two lines. Okay, I have two lines. Let's say this line, and I have this line. Okay, so which line have a uh, larger slope? Any idea? Actually, we don't have no idea because we are not given any particular information. I don't know why I made this such ridiculous example. Let's take a serious example. Okay, so here, here, and here. So here is a line. Okay, and let's take another line. Which line should I take here? And let's take this line. Yay, this sounds fun. So line L1 and line L2, which might have larger, or not just might, which have a larger slope? Line L1 or line L2? And the answer is, okay, let's just go through the basics. Let's calculate the angle. This is theta 1. And let's go to another angle. And this guy is theta 2. So through logic, theta 2 greater theta 1. So tan theta 2 greater tan theta 1. And this is, my friend, a big no. Absolutely not. Now, please don't blame yourself. Actually, you have to blame me because I haven't taught you this one. I saved this for the last for today. Can you believe it? So here, now, to justify this, I will teach you another concept And that concept is da 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 descending and ascending lines. Okay, so what is a descending line and what is an ascending line? Okay, so always remember this line is a descending line, this line is a descending line, this line is a descending line, this line, all of this line will have a negative slope, okay, because they are inclined to negative. Why inclined to negative x-axis, my friends? Can you see they are more inclined to the negative x-axis? That's why these lines from here is as soon as the line moves from crosses this quadrant, as soon as it comes to second quadrant, the line is inclined to negative x-axis, and every line that comes to negative x-axis is a descending line, and this line always have slope negative. In such lines, in comparison, in this line, in between these lines, we can say tan theta 1 greater than theta 2 greater than theta 3. But when we compare this to ascending lines, then our logic will be flawed. Why? Let's discuss. Let's take another set of ascending lines. Now you might ask, what the hell is the ascending line? Now, the lines that are inclined to positive x-axis. As you can see, these lines are in the first quadrant. So these beautiful lines over here, they are ascending lines. Now these ascending lines will also have tan theta 1 greater than tan theta 2 greater than tan theta 3 and so on. So in this comparison of L1, L2, L3, L4, we can say L4 have greater than L3 and L2 and L1 here. But if we compare between ascending and descending, then we should not look the angle. Ascending wins by a mile. Okay, so you might again ask me why theta is higher in the descending, but if you go to the numerical values of tan theta, then here is tan is positive and here tan is negative. So there is no comparison between these lines and these lines. I hope you understood. So we have only two lines, ascending lines, descending lines. Okay, let's just get to a summary of the decision. Okay, this two logic is more than enough for today. I don't want you to get tortured by my very boring lectures, so I'll just summarize. Okay, so first we have got ascending line and descending line. Only two lines, guys. There are no more lines, okay? Just two lines. I will cover in coming days the parallel lines, parallel to x-axis, y-axis. I'll cover that, but for now, just these are enough. And parallel to x-axis, y-axis are very easy. They're just one, two lines. So let's not focus too much on that. First, there are just two lines. Either they go like this or they go like this. Okay? So this is ascending, this is descending. It has a slope of positive because tan theta is positive here. It has a slope of negative because tan theta is negative here. The second thing we learn is slope of line. And I taught you three formulas, I think. The first one is tan theta. The second one is y changes, means the coordinate of y-axis and the coordinate of x-axis change. And the third is y-intercept by x-intercept, isn't it? So there you go, guys. If you can learn only this, I think you will be just fine. I will bring further questions, further discussion in the next class. Until then, just try to revise these two things. And remember, do not panic. It's super easy, it's super fun. Okay? Hope you have a wonderful weekend.